Mechanics of Materials, Chapter 8, Combined Loading. So in this example, we do have a square foundation, the dimensions of 2 meters times 2 meters, which handles a concentrated load of 120 kilonewtons at its center and two bending moment both axis y my 40k kilonewton meters and mx 20 kilonewton meters. We want to know what is the ratio of a state of stress at point A with respect to point B. So we want to know what sigma A over sigma B is. Let's start the problem. So if you have a concentrated load like 100 kilonewtons, you can say every point under this foundation experience a stress like force over the area of foundation, which is 2 times 2, and that's a 120 of 4, and that's a negative because that's a pushing, and that's a negative 30 squared of stress. At the same time, if we have such a moment, so if you look at the nature of this moment, so my, which is our y-axis, it just pushes point A downward, and mx pushes point B and pushes point A outward. So A is under push from my and under push from mx, as you can imagine it, how the effect of mx is on point B is it just pushes point B over here. This kind of moment just pushes point B and pulls up point A. So let's see how we can have the stresses. For example, point A is a downward. The nature of this load, which is distributed all over below the foundation, and a positive pulls up due to mx, which is the nature of mx, pushes point B and pulls up point A. That's mx over ix times ya, which is the distance of in negative y direction, and that's my bad, that's 1 meters. And a negative a push due to my, and that's my over iy, my over yi, that's a push negative times xa, which is again in x direction. We have to travel this much distance, which is 1 meter, to have the stresses. And all distances in both direction, because it's a square and half of the length is 1 meter at each side. So if you replace the numeric value, it's a negative 120 over 4 meters squared, a plus an effect of mx, which is a pulls up. This is a push downward. That's a plus 20 times 1, which is distance, over 112 base cube height, and tends to be 112 2 to the 4th, because A and B are the same, a negative push downward feature of my, and which pushes point A, and that's a negative 40 times 1 over 112 base cube height again, and it just turns it to a negative 30 plus a 15 minus 30. So it just gives us a negative 60 total sport, just turns to a negative 45 kilonewton squared, which is a push down bar by the amount of 45 kilonewton squared. Let's see what happens at point B. So at point B, there is no effect on my, because there is no vertical distance due to this moment. So we cannot create any moment. So my is already the effect of my, because the distance of x for B is equal to 0, it just stands at the center. So we just have the effect of load over the area, which is a push downwards, and also mx, which again pushes point B downward, and that's mx over ix, a push, times yb, my bad, it's y, which is again 1 meter, and which is half of the dimension of our square foundation. If you put to numeric value, it's a negative 120 over 4 meters square, again minus times 1, which is mx, and it just turns it to a negative 30, negative 15, and 45, 45 kilonewton per meter square. And if we want to know the ratio of stress as at point A over the stress at this is a negative 45, this is a negative 5, and that turns to the new value of. Thank you. Solve